Aloha, Rich Halverson here. This is ITS148. Today's the first day of the semester for recordings, and actually the first day was last week. So I'm going to get you started here. Let me share my screen. All right, so here's La Lima. We are 148. This is my student version here, so I hope this looks like what yours looks like. On my teacher version, I got a few more things over here and so on. But anyway, so I think maybe most of you took 128 from me last semester, or maybe you took 128 previously, or maybe you took 111. So each semester my operation gets a little bit better, I think. Not much different this semester. This is the YouTube playlist. All the videos, including this one, are going to go up here in this playlist. There's not anything there now, but it's there. And I can Zoom with you anytime. I spend almost all my time today. There were 6,252 new cases today, and coronavirus. So I spend all my time at home here. But you can text me and we can Zoom, or so same day or next day appointments, no problem. Here's the textbook. Everyone needs to sign up for the textbook. You can click and get to the textbook by you can click on the textbook and get to the textbook, and after you've signed up and everything, it looks like this. And this should be pretty close to what yours looks like. Mine has more on it, but yeah, here's some instructions. So it costs $77, and you need to sign up by the 10th of May, which if you wait that long, it's, you're probably not, I don't know, it's possible you could still pass the class, but, and then they last until June 14th, which is like a month after the semester is over, and that's in case one or two of you might want an incomplete and need a little bit more time, and so the book will stay open for you a little bit longer. This semester, this is 148, and we can look at the syllabus here. I'm sort of transitioning over to more slightly more rigorous content, similar to ITS148. Now, this content that I'm going to be covering in this semester, things like sorting and stacks and queues and trees and so on. Those are different data structures that are very common in programming. They've always been in this course, but not emphasized, and they were not in the SLO, the student learning outcomes. So I've added them to the student learning outcomes. The stacks and queues, you know them, you use them. This is just going to be like the formal, computational thinking definitions of these things and how they're used. Trees, and then searching and sorting algorithms. There's many different sorting algorithms, and in the old days, it would be important that you could code various sorting algorithms. Like at least one so-called O of n log n sorting algorithm, and one O of n squared sorting algorithm is fine. Now we just use sorting algorithms to teach what it means to say an O of n log n sorting algorithm and an O of n squared sorting algorithm. Those have to do with you examine an algorithm, you look at the loops, and you figure out a curve for how much time it takes for the algorithm to execute when the size of the data grows. So when the size of the data is double, does the speed of the algorithm take twice as long, or does it take 4 times as long? And that's what we look at when we're learning how to compare algorithms, computational complexity of algorithms. And we're going to cover that. We're going to touch on that in this class. 228, we get more into that. Anyway, so I've taken some of the important chapters from 128, and we're going to cover those in the first 3 weeks. This is a weekly thing now. These are 1 week at a time, and that's the first 3 weeks. And then I don't remember where we left off in 128, but I don't think we covered some of these upper chapters that rigorously. So we're going to go over those again, and then we go on to the newer data structures and so on, how to manipulate these, how to store data using these data structures, and then how you manipulate them, how you choose which one is best for what you're trying to do, and so on. Another thing I'm going to do this semester is I'm not going to have so many lab activities. Okay, maybe I got here like 2 a week or something. Maybe there's 3 a week sometimes. So maybe it's just always 3 a week the first time, but then the rest of the time 2 a week. And I'm gonna use the other lab activity. There's more labs in there. I'm gonna use those other ones to really try to teach you the concepts of what you need to know to do the lab activities that are assigned. And I'd like to give you less help. You can still still collaborate with your classmates. Just don't give each other the code. Help them understand and write the code. Give them hints. Hints is a good thing. It's good for you and it's good for the other person. So I encourage that. And then later on, we're going to get into these things which I call platform assignments, and you're all going to be assigned a Linux server machine, a virtual server, and you're going to be doing assignments on that. And they will be auto-graded too. It's something that I've created. Do I have any assignments assigned? No, I don't have any assignments assigned yet. I can show you. Oh, because I haven't copied over any assignments yet into this. Anyway, but that doesn't come till way later. That's going to be, in February. I'll give you the first one. So I guess I can start today with see a couple more things. Participation verification. It's a new federal law, and we have to actually sign off that everybody who's registered for the class has actually started participating. And the reason for this is because I think one of the reasons is sometimes mistakes happen, and someone never realizes that they're registered for a particular class, and then they end up at the end, they want to get their money back or whatever, and that's a problem. In fact, when I first started teaching at KCC, I had a student. I was teaching ITS101, and I had a student that was in there for 5 weeks, and it turns out she was supposed to be registered in ITS100, which was next door, and she had the textbook and everything, and she didn't show up on my list, but she had everything. She sat in front of the class every day, and it was an older student, and so I said, she wants to sit in my class. That's fine. And later on, we find out that she's supposed to be in Tom Moore's class next door. But anyway, so that kind of thing won't happen anymore. So to verify your participation, Casey has already verified his participation because I see he's here, or I see that you're here. But really, what really a good thing you can do is go to the forums and do this one. Why are you taking this class? And I don't care what you say, just put down the reason. Oh, I needed to graduate or whatever. And then that counts, and you get credit for that too. You have to do these forums. There's less forums this semester than last semester. I think there's only 4 or something. And then the other thing you can do is you can, of course, if you purchase the textbook, I can see who purchases the textbook, and that of course would count as participation. So anyway, that's very important. And I think I got to get that done by yeah, we got to turn that form in, like, I think we got to do it tomorrow. No, we have to do it by Friday. And then we have to actually turn the form in on Monday. All right, so let's get started with what we need to do for this week. And basically it's some challenge activities. It's sections 3.1 to, it's all the sections. Okay, I assigned the whole textbook, the whole chapter, huh? Okay, well, you should remember this from last semester anyway. But it's because the types, the basics here of types is, there's two, when you're comparing programming languages, you compare the types they support naturally. And what else do I have here that's important? In strings especially, strings is really important. Strings is parsing. It's how you extract data from stuff. And then lists and dictionaries are real important too, because that's unique to Python. Python really has advanced support of these data types built in, and so that's why I go over them. And if you're coming from the Java world, or from the C# world, or from the PHP world, you'll be surprised at how simplistic but powerful these types are. And then we're going to get into the real stuff, and that's exceptions. And here we're talking about searching and analysis of algorithms, and that's where I talked about O of n squared, and so on. So we'll get into that. Let's start with this chapter 3. Okay, so first we cover the different types of. This is the first exposure, other than chapter 1, then to all the different data types, and sort of presents them and emphasizes the differences between them. Strings are sequences of ordered sequences of characters, and you assign. You have variables, you assign variables to string values like this. Here's a little example game that you can play where it reads 4 words and makes a funny sentence or something. And so, this is a simple string example where you're stringing together, these words embedded in other phrases, and you create that. Anyway, so make sure you understand the difference between literals and variables, and make sure you understand all this. This is how you can make longer ones without having to have a embarrassingly long string all across the page, and you can't see the end of it, or you word wrap it, it looks funny. You can just do this. That's unique to this language. All languages have this, but this is how you do it in Python. All right, you can refer to characters in the string by indexing them, just indexing them like this. This is just like how you index elements in a list, so don't get confused. It works the same way with characters in a string. Now this is a character, right? It's capital A, in fact. But this is different than this, because this is a string and this is a character, and characters and strings are two different kinds of things in Python. They're very similar, but they're different. So you got to remember that when sometimes you're getting um, a type error. You know, you get an error saying you're trying to do something with a character that you can only do with the string, you know, that kind of thing. So you shouldn't get confused with that. And so you cannot do something like this because you can't, because you're trying to change like one thing inside a string, and strings are immutable. You know, you can't change. Immutable and mutable is the same meaning as the coronavirus. The coronavirus mutates. It means it can change. It goes into somebody and comes back out and, you know, gets somebody else, goes to somebody else, and it may have changed a little bit. Omicron is a mutated version of the of Delta, or, you know, Delta is a mutated version of the original one. Same term. Strings are immutable. You can't change strings, but you can. But there's lists you can change. So something like this might look exactly like if you had a list called alphabet. So it wouldn't be like this anymore. It would be square brackets and elements. If you had a list called alphabet, then this would be perfectly valid, and you would be assigning a value to the first element in the list in the alphabet list. This would be assigning a B to the second element in the alphabet list. And that's okay because lists are mutable, but strings are not. Okay, I hope that made sense. All right, so here's how you concatenate strings. Just use a plus sign. Most programming languages use a plus sign. PHP and Perl use a period, just in case you're interested. And here's, so make sure you understand, make sure you understand this. Here we're, okay, after the following executes, the value of address is 500 space floral space avenue, 500 space floral space avenue, so that would be true. All right, here's a challenge activity, and you remember challenge activities. You should be able to go through this yourself. You've done it before. It's the first one in strings. So you can do these. But just in case you've never seen this before, I'll do the first one here. Okay, click start. All right, so you just fill in what the answer is. What's the program's output? Oh, gee, this is a tough one. AERITH, return. Should get that return in there. And yes. I wonder if what would happen if I didn't put the return. I'm going to try the next one. I'm going to say cloud. And I'm not going to press the return. Uh-oh, missed the return. Okay, so yeah, you got to make sure you put the return in there. And in these challenge activities, you just type in some code, and it tells you right where to type in the code, so you can't type the code in here. You can only type code in where it's light. It's not shaded over here. And so your solution can go here. You can erase this. And what are you supposed to do? Write type 2 statements. The first one reads the user's input into person name, and the second reads user input into person age. Use the int function to convert the person age to an integer. Oh yeah, because we want to be able to do this operation. If we don't change, yeah, okay, so if we don't change it into an integer, then that operation will not work because you're trying to add, this is a number, and this would be a string. And so this means concatenate. So you have this string and you want to concatenate a number. It's not, you can only concatenate a string onto a string. Okay. All right, so basically you're just asking for the person name equals input, and you should put something in here, enter your name, but it might not want that. Whatever. And then for person age, it's also an input, but should be like that. But then you got to convert person age equals int person age. That should convert it into an integer. And then you can do this. I think that's right. Let's see if this works. See, it doesn't want you to ask the user, or it doesn't want you to prompt the user. They want the user to be able to read the mind of the program. But I think this is okay. Okay. All right. So so that's how you do these challenge activities. So you're either going to do something like this, or you're going to write in a little bit of code, and keep on doing it till you get it. And once you get it correct, you get all the points. And so it's okay to make mistakes. In fact, I do it often because I like to see what happens. I like to test the robustness of the grader here. All right, so let's list. Okay, so those are strings. Now there's lists, and I'm keeping track of the time here. After you've defined the list, you know, the way you manipulate the list is very similar to strings. Strings and characters. Strings are made up of characters, and lists are made up of elements. By the way, all the other languages call lists. Python calls them lists. All the other languages call them arrays. So if you're ever if you're ever working on a problem, you know, and you know, you're coding in Python, and you know it has to do with how to sort an array, or so how to sort a list. Let's say you have to, that's an assignment. And you're Googling it, you can say how to sort an array, and it'll probably come up in a different language, but it should be easy to translate. Anyway, just thought I'd point that out. They don't all have to be the same type, which is kind of nice. Here they are. And so what are we doing here? The following program prints a list of names. Try adding your name to the list and run the program again. Oh, okay. How about if I say Richard? What did I miss? Huh? I missed the closing quote. So I should spend more time explaining these runtime these error messages, because they're if you can read the error message, you can figure everything out. So this is just saying that there's a syntax error. There's invalid syntax. We're defining a list, and there's something wrong with what I've typed in. It doesn't understand what I've typed in, and that's it. Now, this arrow thing we can see here from here. Let me do this. I'm gonna do this. I'm gonna take this out, but I'm gonna remove this to make it shorter. Okay, same error, right? I left out that. Now it's easier to see. It tells you where it first noticed the syntax error. Now, the reason it's over here, the reason it's pointing to J, because it is reading this whole thing, that all the way up to there. That's an element, okay? Because it begins with a quote, ends with a quote. That's an element. Following an element, there should be a comma. There should be either a comma or there should be one of these. And there's not. There is a J. What's a J doing there? So that's the syntax error. The parser goes along, goes, first element, that works. Second element, okay, that works. What's the J there? It should either be a comma or an end bracket or a space. Give me a space. So that's how you read that. Write a statement that creates a list of my nums containing the elements. Okay, so this is probably just numbers. So anyway, you should be able to do this. All right. Accessing list elements. Okay, here's kind of what we're doing. We've got a list here. we've created a we have a list called prices. It's got 3 elements. The first one is whatever the value of this is. This is a variable, so it's whatever that value is the first element. Whatever that value is the second element. Whatever this value is the third element. These values are defined right here. So it's actually the numbers that are in here. And then so this is how you reference the first one. This is how you reference the second one. This is how you reference the third one. See 0, 1, 2. Kind of like strings and characters. So initialize a list of short names and sample out. Okay, so you want to create a list here. A list, blah 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 blah, end of the list, and you want to define these things in the list, right? So that would be a list, I think. So now here we see that lists are mutable. You can mutate them. You can pass a list to a method, and it comes back, and the list is different. You know, it mutated. Can't do that with a string. If you want to do something like that with a string, you actually have to create a new string and return a new string in place of that old string. Okay, so it's different. So here you want to make sure that, oh, the third element, well, that'd be 2, because the first element is 0, the second element is 1, the third element is 2, index of 2. So that's what that is. You can remove. They're not only mutable in the way that you can change one of the elements of the list, but you can remove elements, and you can insert elements in the middle of the list. So there are methods to do that. This method, you have a list.append here like this, list.append, and that appends something onto the tail end of the list. Make this bigger. Oh, it's pretty big already. Okay, so that's, and this one we'll take it, like take it off. Oh, you give it the index, so it removes that element. And you know, if you were thinking of it as a physical list, they would you remove the fifth element, and the rest of them sort of shift up because there's no space in between anymore. But anyway, that's, so to do that, there's the pop method, and then so this is an index. For remove, it's actually the value, so it goes and finds the first one that's got that value and removes that. So those are 2 methods to help you mutate the list. So it's append, pop, and remove. Okay, so here's some other useful functions that you can use to operate on a list. These take lists as arguments. The type of argument is a list. So here, just return the number of elements in the list. This will append 2 lists. It produces a new list by concatenating list 2 to the end of list 1. So this is a new list. We aren't mutating anything here. We're taking 2 lists and sticking them together, producing a new one that's like a copy of that. This tells you, searches and finds the minimum smallest value in the list. This finds the maximum value of the list. This adds up everything in the list, assuming they can be added. And this find the index of the first element of the list that matches this value. So that's pretty cool. You have a list here, and what is the index of the element that has that value? And this counts up the number of occurrences of that value in the list. Excuse me, I'm going to turn my air conditioner off. So those are a nice summary of list of how to mutate a list. What is the value of that? It'd be 1, 2, 3, 4, 5, 6, 7. I would say it's, oh, you got to start it first. I would say it's 7. All right. Now there's also tuples, and tuples are lists, but they're not mutable. They're immutable. Once created, the tuples elements cannot be changed. A tuple is also a sequence type. So it means there's an order. With sets, there's the next one is sets. Sets doesn't matter the order. It's tuples, there is an order, and I guess that means you can have repeating. You can have more than one element of the same value in a tuple. And you can use so there's indexing, there's a length and so on. So it looks like it's just like a list, except for it's not mutable. It's immutable. A tuple is not as common as a list in practical usage, but a programmer can use it to make sure, to ensure values don't change. You want to pass it around, have some rogue method go and mutate their list. Can't do that with a tuple. All right. So here it looks like some sneaky bugger is trying to mutate that tuple here. There's a tuple. You define them differently. You use parentheses instead of square brackets. So this in this program they're using parentheses. So it's a list that's not mutable, a tuple, and prints them out. Refers to them just like you can in a list in a string. But here we're going to try to change it, and it's not going to let you do it. See, tuple object does not support item assignment. Does not support item assignment. It means you can't assign an item. You can't. This is the second element you can't assign a value to it. All right, so that's create a new variable called point. That is a tuple containing the strings, point equals, just gonna copy it. Except for get rid of this, make a comma, and put a close. Is that the answer? Yeah. All right. Here we're just how to make a tuple. You can do that. Use parentheses. Program that commonly captures collections of data. A named tuple allows a program to define a simple data type that consists of named attributes. Okay, so this is a tuple. Oh, no. What? Oh. This is the tuple, but it's just a list. It's a list. And this is the name of it. Car equals, no, wait a second. No, I'm not saying that right now. I've never used named tuples. So anyway, it's easier for you to read this and understand it than it is for me to try to read it and explain it. And I'll probably say something that's not quite right. So here we're defining a named tuple called player, and okay, I'm not sure. I'm going to say something that could be wrong, but it may be that oh yeah, Okay. I think all that's happening here is that this is actually a list. So this part of this name tuple is mutable, but this is not. So anyway, yeah. So why don't you so make sure you understand that. I don't imagine I'd ever assign a program which would where the best data structure would be a named tuple, but you know, maybe I can think of something, I suppose. All right, sets. It's unordered and oh, and you use curly braces just like dictionaries, but we haven't gotten dictionaries yet. But curly braces is either sets or dictionaries, and so this creates a set. This creates a set. It's gonna eliminate the duplicates, but our sets, they're iterable. Okay, it's an unordered collection of unique elements. Elements are unordered. Yeah, they're unordered, and elements are unique. Okay, that makes sense. A set can be created using that function, which accepts a sequence type iterable object. By iterable, it means you can sequence through it. There's in Java, you actually define an iterable in a class to anyway, whose objects can be elements can be inserted into the set. The set literal can be written using curly braces. All right. So here's how you create a set. This is gonna get rid of the duplicates when you create a set from this. See, this is iterable because you can sequence through it. And modifying sets. So sets are mutable. That's what I was trying to figure out. And so you can have pop and remove. There's no order. So pop removes a random element from the set. I guess that can be useful. And this clears it. This adds the elements in set 2 to set 1. It means it takes this set and adds them into set 1. This says how many there are. This adds a single value to a set. Remember, order doesn't count. So it doesn't matter where it ends up sitting. And oh, it raises a key value error if it exception if you're asking to remove a value that's not there. Okay, so here we're defining a couple sets, and this adds a single element to the set to the first one. This adds all of these ones to the first one, and this removes Dean, and this clears them all. Oh no, this is different. This clears this set. So this is how it ends. Makes sense. You got to step through this to get the points, and make sure you understand it. Challenge activity. So you're just gonna write the statements to remove a name and add a name, and then you're gonna print it back out again. So to remove, you use the remove method, and to add, you use the add method. Just like this. All right, so you can do that one. Okay, so there's comments, there's set theory operations, which you probably are aware of. You can do intersection of sets, which returns a set of elements that is common in all the sets. This returns a set that contains all of the elements in all these sets. Of course, with sets, there's no repeats. So, you know, the final union set, you know, is going to be equal to the length of all of the sets or less. If there's duplicates, of course. This will return the difference, returns the set containing only the elements of the set that are not found in any of the other sets. So, it's basically, you have a set here, and then you're going to subtract out all of these sets. And if there are elements in any of these sets that are not in this set, it does not cause an error. It's just, they're just ignored. So what it is it's the intersection of is that right? No, it's it's not. No, it's not. No, that's not right. But anyway, so in this in difference, the order matters. I mean, set A minus set B is not the same as set B minus set A. Whereas with the other ones, it makes no difference. All right, and then this is a symmetric difference which contains only elements that appear in exactly one of the sets. Okay, so that's like, what's the difference between that intersection? Oh, only one. Okay. No, it's the opposite of it. It would be like the opposite of intersection. Okay, right. Okay, so anyway, those are common set operations. And so with these operations, you can solve these problems. They're kind of tricky. All right, what's next? See, we're this 9:58. This is 15 more minutes. Dictionary basics. In other languages, this is called an associative array. They have there's key. Every value, the value 10. These are the values 10 and 7 are the values, but each of these values has a key, and this is the key, and this is the key. So you're looking, what is the value of a key? What is the value for Lionel Messi? Well, it's 10. Okay, so that's, and the way you define a dictionary is with curly braces. And so it's like sets, right? Oh no, oh yeah, here, sets, curly braces. Oh yes, okay, got it, okay. All right, curly braces. All right, so dictionary basics. So make sure you review this. Make sure you're familiar with the methods. Not a summary of methods here that comes along with dictionaries. So anyway, know how to add an element to a dictionary, how to access them, so on. So when you print out a dictionary, it prints out like this. Anyway, so that's dictionary common data. Here's a nice summary of them, and let's here's a nice summary of them, and so make sure you understand the differences. Let's Python is strongly typed, which means you can't just, there is some implicit conversion, but not nearly as much as other languages. See here you're actually mixing types, but it's okay. It'll return a floating point number, and so on. And otherwise, you use these methods here. All right, so that's string conversions and binary numbers. We don't do much of this. But you probably remember this: binary numbers base 2 instead of base 10. Each position can have as many values as the base. So base 2 numbers each position can only have 2 values. Base 10, each position can have 10 values, 0 through 9, and so on. And there's standard algorithms for converting between decimal numbers and binary numbers and back. And so this reviews that a little bit. And if you ever need to write a program to do it, you can just search the internet. This is pretty important, the string formatting. Did I add this? This could have been something I added this semester, maybe not. Different ways of string formatting. I think maybe I did add this. So there's the formatting using F strings and F strings, which I don't think we even did much of last semester. These are how to do it using F strings. You got formatting stuff depending on how you want numbers to display out and so on. And then, is that it? Those are all the string. Of course, and there's other ways to, oh, this is formatting strings. This is not for printing. Okay, well, anyway, so you can review this, and this is an option for formatting your output. All right, so these are the labs. Phone number breakdown, and you should remember this one from last semester. And basically, you're just reading in something like this, and you're converting it to something like this. And so they want you to use mod and integer divide. Is that what they want you to use? Okay, you don't have to do it that way. You can do it with by treating this as a huge integer and doing integer divides and mods, or you can treat this as a string and just take slices of the string. I wonder if that would. All right, I'm going to try both of them. I got 10 minutes here. So one way to do it is, oh, here we've converted it to an integer. Okay, cute. So I'm going to do this. PN equals STR phone number. I'm going to convert it back into a string. And then I'm going to say area equals PN. See, this is too easy. 0:2. Exchange, which is the next 3 digits, equals PN 2:4. Zero, 1, 2, no, 3. Oh no. It's 3. It's 3 digits. So 0 to 3, 4 to 7, and then last 4 equals PN 8982. 12. Is that right? Yeah, there's how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it only goes to 0, 1, 2. This should be 0, 1, 2. This should be, oh no, I'm sorry. Go to 3 to 3, 4, 5, 6, 7, 7, 9, 10, 11. I'm getting my things mixed up. Because this goes 0, 1, 2, 3, 4, 5. This should be 6. And this should be 6. And I'm going to make this 10. And I'm going to say print. I'm going to say new num formatted number equals plus area plus exch plus last 4. And then I'm going to say print fn. Let's see what this does. And I'm going to do this number here. Doesn't matter what number I use. And I'm going to run it in development mode. And what do I get? Looks right. I wonder if I'm going to get the points. Oh, I got all the points. But anyway, they want you to do it this way. I'm wasting your time, but this is a good exercise to go through. They really want you to do it this way. Get rid of all this. They want you to do area. So the first one is the area code. So area equals phone number you're hacking off the bottom 7. So it's phone number divided by it's 10. Is it a million or something? 1, 2, 3, 4, 5, 6. I'm gonna do this one step at a time. Development mode. What is this? Okay, that's wrong. Oh, that's wrong. Okay, need one more 0. Okay, I got my 800, and now I want to get my I want to get the 7 digits. So I'll say phone 7 digits equals area, no, equals phone number mod, whatever this is. And now let me print phone 7 digits. And I get this 5551212. So now I got phone digits, and I can do exchange equals phone 7 digits. This 1000, I think. No, 10,000, I bet. And so print exchange. Okay, put parentheses in this Python 2. I don't think you can. So I'm gonna leave that, see if it works. Okay, I got the 555, and now I need this last 4 equals phone 7 digits mod this. That'll give me the bottom 4 digits. And so then when I print last 4, I get 800, 555, 1212. So I have the three things. It's the area code, the exchange, and the last four digits. You can put that together into a phone number. All right, so that's that one. List basics, it's only three minutes left, but I'd like you to just go through these and try to do these. And basically you're just recalling how a list works. And just follow the steps. Define a list containing these four elements in that order, and then define another list, and then define a third list by concatenating the two, and then append to this append the user input to the end of our list, so append it to the end of this list, and then replace this element in our list with this element. And so anyway, just do all these steps, write statements to do these steps. That's what it has here, and then that should be fine. And you're just reinforcing the lists. This is sets, same thing. It's just an exercise to go through and make sure you understand how to do each one of these things that it tells you to do. I mean, so it's how do you define a new set containing this? How do you add a couple things to the set? How do you, add more, and so on? And how do you remove from a set, so on? Do this one, get that one right, and that should be it for this chapter. All right. Are there any questions? Oh, there's a chat. Sorry, I got to pay attention to the chat. Okay, so good question. How to I'm sorry, Rourke. I didn't. Okay, 3.13 challenge. I got a couple minutes here. Let's go look at that. 3.13 must be in here. Okay, so we have this. Okay, so your code looks like this. I'll tell you what, I'm gonna grab it over here, okay. Okay, you just wanna know how to put a space in there. So you've got some code here, and then you got something that looks like that, and you wanna put, this is the current time, and then the city and the state. Well, you just put a space like this, and then another space here. Yeah. Share screen. Yeah, here we are, challenge 3.13, and your code, this is already defined, and then you have some code here to ask the user what my city is, and then you ask the user what my state is, and then you want to print it out. You want to print out, this is the time, this is already there, and then you want to print out a space followed by Houston, followed by a space, followed by Texas. Yeah, okay, yeah, so it's just this, and then you put a space in. So that's how you put a space as you concatenate. Does that answer, does that work? All right, so you would have something like, you're gonna ask the user this, but my city would end up being, And my screen's still not okay, and then you have my state equals Hawaii, let's say, and you have that. What does this end up doing? Oh, this is a challenge activity, so it's not gonna tell me my answer. Right? Sorry, it shouldn't have the dots there. Okay, so so it's pretty close because well, I'll put the right answers in here. So you're supposed to actually write code to ask the user. Oh, that's because yeah. All right. All right. I guess I'm just gonna have to. My city, my state. Do not provide a prompt. All right. It's a challenge activity is hard to give you hints because it just doesn't execute your code. So you actually just want to ask the user what these are. All right. So anyway, your question, which was a good question, and I ended up giving you the answer here. But to add spaces in between there, you just concatenate on a space. You're concatenating 5 strings. This is a string. 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 All right. So thank you very much, and we're going to have another session later this week on Thursday, and so I'll see you then. Make sure you do your form question or do something so I can verify that you're in the class, because otherwise you get stuck on a disenrollment list, and then you have to contact me within a certain period of time, and I can put you back on if that happens. But just don't make sure that doesn't happen. All right. Thanks for watching.